Okay, good evening, everyone. A warm welcome to all participants in today's webinar on opportunities and challenges in NavIC. So before starting webinar, I would like to give you a brief details about our technology innovation hub. Our hub is focused on positioning and precision technology in the domain of position navigation timing. So the TAH is funded by National Mission on Interdisciplinary Cyber Physical Systems, Department of Science and Technology. So basically, our hub serves as a platform for researchers, industries, stakeholders, and startups to foster innovation in PNT domain. Majorly, we have four objectives to drive innovations. One is technology development, where we promote technology development through research projects, technology breakthroughs, and industry collaborations. And another one is human resource development, where we enhance human resource development through skill development programs, fellowships, internships, and also the training programs, similar to what we are doing today in webinar of NavIC, promoting NavIC. Apart from that, we have startups and entrepreneurship. So we nurture startups focused on PNT domain through supporting programs, and we also support startups through funding and other initiatives. And the last one is the collaborations. We foster international collaboration and also the national collaborations to share knowledge and drive innovation in the domain of PNT. Again, you can go through our website, so you can find more information about our objectives and what we are doing and what we are working on that. So I think we can go ahead with, I would like to welcome our speaker, today's speaker, Dr. Anindya Bose. So Dr. Anindya Bose is working as a senior scientific officer in the Department of Physics, the University of Burdwan, West Bengal since 1996. He is alumnus of CSIR, NPL, New Delhi, and International Space University, Strasbourg, France. He is recipient of URSI Young Scientist Award, senior member URSI. His research interest includes global navigation satellite system, microwaves antenna, and communications and e-learning. He has completed and is working with 14 sponsored R&D and manpower training projects sponsored by Government of India agencies with a financial support of more than rupees 2 crores. He leads the state-of-the-art GNSS laboratory Burdwan at Department of Physics in the University of Burdwan. So the University of Burdwan is a consultant to the Indian GNSS industry and a member of LIT 22, Panel 5 of BIS for standardization of NavIC receivers. He has more than 150 applications in journals, conference proceedings, and holds one software copyright. So thank you, sir, for participating, and thank you for your time and accepting our invitation. Over to you, sir.
Okay, thank you very much. Thank you very much for your kind introduction, and a very good evening to all. And thanks for giving me the opportunity to share my thoughts and my experience with NavIC. So thank you very much. Without wasting much time, directly let me go to my presentation, and I'm stopping my video to share bandwidth, to save some bandwidth. Okay, so let me go to the presentation directly. So can you see it now?
Yes, sir, we can see that.
Okay, thank you very much. So well, this webinar is on opportunities and challenges in NavIC. As I'm already introduced, I'm from GNSS Laboratory Burdwan, and this is my Twitter handle where you can follow me. And it's an excellent opportunity to also, I can see many old friends. Varad is there. Professor Lakshmi Narayan is there. Hello to them and my best regards. The agenda today would be, yeah. The agenda today, how I want to proceed is like this. So just to start with, maybe a few minutes on the basics, which I think a recapitulation is needed. Then the main topics, the multi-GNSS from India. Okay, so multi-GNSS from India, NavIC introduction. And then from the potential point of view, I will talk about the differentiators. What NavIC has in comparison to other GNSS or other regional system for our country to exploit and use. Then NavIC application potential vis-a-vis the global market trend, then challenges and road ahead, and finally the upcoming opportunities and events on NavIC. What I think this is a good platform to discuss with. Well, so I start with the GNSS market, right? So I think a lot of people here who are basically want to see how the market is there. I've taken all the slides from this one. Here is the link, that is 2022 ISPA and GNSS market report. Directly I'm taken from that one. So if you look into the total GNSS market, you can see the expected market from 2021 to 2031 has been predicted to be $2,360 billion. So you can believe what a large market is. So for consumer solution, tourism and health is very important, on which I will talk about road and automotive. And other sectors are around 10%, which is say around $377 billion. They takes care of the urban development, culture, heritage, emergency management, humanitarian aid, maritime, fisheries, aquaculture, infrastructure, other segments, aviation, and drones, rail, and most importantly, agriculture, what is pretty important for our culture, for our country, and on which I will talk about. So, so you can see a huge market is rather, I would say, predicted for the next 10 years, up to 2031. If you look into the region, if you can see, so if you look into Asia Pacific, you can see from 21 to the end of 2031, Asia Pacific consists a huge part of the total market. Similarly, so what are the areas that the consumer solution, tourism, and health to be a major issue? So this gives I think this gives me at least a typical feeling that how GNSS is being popular and pretty important business globally. And then my takeaway is why not take a part of the business into our country and also by our people? So that the question what I always pose. And I think the Technology Innovation Hub at IIT Tirupati would be a differentiator and catalyst in bringing a part of this huge market into the Indian region and basically into India. On the other side, how good we can use the technology, an excellent technology for the benefit of the life of our people, right? So these are the two aspects. Obviously, firstly, how we can bring a part of the business into our country, and second is how we can use the technology together with the business for benefit of the people of our country, feeding, making their lives and livelihood much more easier. I see it that way. So now, the very basic of any GNSS system, global aviation satellite system, it consists of a few satellites, right? And which is called the space segment. Then user segment, where you and I believe, and we use the satellite signals, what is coming from them, to convert them into PNT, position, navigation, and timing. And in some cases, it is told PVT, that is position, velocity, and timing information, so that they can be used for different applications, both in case of consumer application, secondly, in case of scientific application that will intangibly support the commercial applications. So basically, the concept is as because for knowing our location in 3 dimensions, we need 3 coordinates to know, so 3 unknowns. Together with that, time is another unknown. So we need 4 unknowns. And getting 4 unknowns, we need at least 4 satellites, signals from 4 satellites, and using them, we can find out our XYZ, which we can convert into more tangible coordinates of its latitude, longitude, and altitude together with time. Okay, so this is the very basic of any GNSS system, be it GPS, GLONASS, etc. in case of NavIC also. So we are living in a multi-GNSS scenario, right? So current global system, which are fully operational, they're GPS, then GLONASS from Russia, Galileo from European Union, and finally BDO or BTS from China, which are fully operational. Their global system, they cater the need of the users globally. And the regional system consists of UKGNSS, quasi-Zenith navigation satellite system of Japan, that is also operational. They have got 4 satellites in their constellation, and of which we will talk about Indian radio navigation satellite system or navigation with Indian constellation NavIC, which is operational. The beauty is, although we talked about that we need 4 satellites for knowing our XYZ or latitude, longitude, and altitude, if we look deeply into the scenario, there are more than 130 satellites now operating from all these constellations. And if we look into the Indian scenario, India is located in a geographical position so that they can exploit, all the users can exploit the benefit of signals from all constellations. So some time ago, we have done an experiment. So this is the scenario on the right-hand side. It is the data, that means the sky plot. That means with respect to our location, that means the central location, how we see other satellites. That means all constellation. So we can see we are getting approximately 54 satellites. The case is also true for western part of India. We took data from our from SDNIT, Sardar Vallabhbhai Patel NIT, with a support from our friend and colleague Dr. Shweta Shah. So there also we found that 54 satellites in view and 45 are being used for navigation. And before that, some time ago, the Multi-GNSS Asia Consortium, which is a part of GNSS Asia, so they predicted that this area would be the GNSS hotspot. And really, we have seen that this is the GNSS hotspot. And this is the picture what I have taken for using my smartphone just in front of my home, standing in the ground with lots of obstructions. Still, we can see nearly 30 satellites we can contact. We can see or visit. So what is the case that if we now see, just a minute. Sure. Okay, so I wanted to give you this feeling that, okay, this is the real life scenario as of now. What is being seen from my laboratory? My laboratory is, I will tell that it is some 100 kilometers west of Kolkata. You can see so many satellites are visible. And if we look into the sky plot, real-time sky plot, it is just what's happening now. So you can see from here nearly 50 satellites. If you add them 8 plus 5 plus 6 plus 16 plus 3 plus 6 plus 3. So many satellites now they are visible. So the main point is, what I always talk about, the main point is, okay, we are getting 50 satellites. So what's the fun? How much we can utilize our expertise, our competencies, the students, researchers, utilize our competency for the benefit of the people of our country. That's the main question. Otherwise, getting 4 or 50 satellites, the beer no.
Sir,
please.
Sir, sorry to interrupt you. So
Yeah.
your voice is low, little low. Could you please increase the volume?
Hello. Okay.
Yes, sir.
Okay.
Your voice is low.
Now.
If you could more.
Hello. Because I'm
Yes,
using
sir.
microphone. Okay. Is it okay now?
Yes,
now
sir.
it
Yes,
is
sir.
okay. Yes.
Okay.
Okay.
Sorry. You should have told me earlier. I'm very sorry.
Okay.
Okay. No problem. Now, so let us concentrate fully on NavIC. So NavIC is a completely indigenous solution, a regional navigation system. What has been actually planned after the experience of our defense forces during the Kargil war. In many times, the service of the other, mainly GPS, was denied in the conflicting zone. So from the reports of the defense forces, the government planned that we should have our own system, basically from the strategic point of view and obviously from the business point of view. So the responsibility was obviously given to Indian space research organizations, and like many other events, they made us very happy and proud. And they came up with the solution of NavIC with a 7 satellite constellation. Now one more has already been launched in last month. So you can see in a 7 satellite constellation what was the original plan. So 3 of them are in a geostationary orbit. So this one, what is called the IRNSS or NavIC 1F, 1C, and 1G. They are in geostationary satellite, and two in each constellation. There are two inclined GSO with their equator crossing and 55° and around 112 degree east. So these are the two inclined geosynchronous orbit. And here in each orbit, there are two satellites and they work in a complementary manner. So when these two are close together, these two goes far away. That way, I do not know from where this came. Do you see a blue line across the screen, or it is in
Yes,
my
sir. Yes, sir.
I don't know how to.
Somebody annotated that one. Okay, we can disable the annotation on the screen. That will solve the problem.
Okay. Anyway, so better not to waste time. Okay, so this is the constellation, and we subdivide the total service area. Obviously, being a regional system, it does not cover the whole of the world, and it is not planned to. So from the Indian landmass, around 1,500 kilometers from the Indian landmass, it is called the, just because it is creating, rather, I would rather say a bit of disturbances. So let me once again try with this one. Okay, fantastic. So from the 1,500 kilometers from the landmass, so this is the green area where it is called the central service region or the primary service region. And because of these constellations, so this region from the eastern part of Africa to the western part of Australia, you can say, this is called the extended service region, where obviously the service quality would be a bit inferior. Okay, no problem. So so what are the basic differentiators of what NavIC is providing us? So I will discuss them one by one in more detail. But to conclude, or to make it concise to it, signal from high elevation angle over the service region. So if we look into it, so this type of maps, we call them sky plots. That means at the center, what I already have shown you, the user is there, and these are the elevation angle. So this is 90 degree, and this is around 0 degree. So this is the horizon, and these are the different azimuth angles. So what we are showing here, so these are the GPS satellites, and when we are adding the NavIC satellite in squares, you can see the NavIC satellites, all of them are nearly more than 60 degree elevation angle. You may ask why? So I will answer that later. Second is the very typical advanced signal, but any other system do not have, and which provides us higher horizontal accuracy and jamming and interface protection. And third is the alert message service. So NavIC, along with the PNT signal, it provides text message service, what any user can take the binary data from it and decode it for generating alert message service for high tide, tsunami, cyclone. And when these types of things are not there, the system shows that what are the good places for fishing, so the fishermen can quickly go there, catch their fish and come back. So to make their life simple, once again, what I told earlier. Second is there is certain advantages of the S-band signal from the atmospheric research point of view. Third is advantages in atmospheric research. Okay, so these are the main points of what I need to discuss in more detail. Although I told that, okay, we are living in we're living inside a GNSS hotspot where at any point of time 50 satellites are visible, including NavIC. But a very strange thing that came into our attention in early 2017, 2018, like that. The thing is, so this is the case where we are using GPS known as Galileo. So three constellations together. But if you look into the scenario, you can see there is no satellite above elevation angle. Right. So we plotted this. So this is the maximum elevation angle from any constellation. So you can see many of them are going below 40 degree. And together, sometimes of the day, we are getting maximum elevation angle of the satellites. That means at what angle we can see from the horizon, we can see the satellites. If you can see, it is above, even above 60 degrees, there is no satellite, right? It is coming below 60 degrees. So what is the problem? The problem is, take the now case, suppose in this particular situation, when it is occurring, some user who is in a critical mission, he is entering or she is entering into a location where the downside, that means the bottom side, up to 30 or 35 degrees, is completely blocked. So what happens? He or she is not getting satellite signals from the lower elevation angle, and due to the typical problem, above 60 degree elevation angle, there is no satellite, and yet we have seen the scenario. So during this affected period, just inside our city, in a normal road, we moved on a motorbike. We have taken a GNSS receiver, and you can see the scatters are very poor. Whereas during a normal period, you can see the scatters are quite good. That means the solution quality degrades because of the poor satellite geometry, and we have seen cases where for a few minutes even, because there is the user cannot get 4 satellite signals from that patch. Complete outage of navigation solution occurs. So this is the problem what we noted. And also when we took into consideration the value, also the time diminished, but still it remains. So once again, we did the experiment. So this is in this type of alley. We took the GNSS that side of a bicycle. So here you can see there is no satellite above 60 degrees. So you can see the scatter plots. And here is the normal thing. So you can see the scatter of the solution. So better solutions in a normal position, but you cannot expect that every time the system operators would give us, because they develop their own system, keeping in view their interest. So what we saw, so once again we collected the data and played it back using the record and replay system. So you can see, so it is the time, and the solution success rate in GPS mode is less than 45 degrees. When the lower elevation angle are blocked and the satellites are glowing, all the satellites are going below 60 degree elevation angle. We tried GPS, GLONASS, GPS plus Galileo, and GPS plus GLONASS plus Galileo mode. The solution success rate is around 75%. So 25% of cases we are losing solution. That means there is no solution. So the question is how to get rid of the problem. So consider the very typical constellation pattern of NavIC. It is coming from 40,000 kilometers above from geostationary Earth orbit. So this is the NavIC visibility. Don't we don't want to go detail into it. So these are the affected areas. So the dots are the affected areas where this type of problem occurs. Why India is also included here. But when we add NavIC to it, you can see here over a large region of the globe, this problem completely disappears. That means you get always at least one satellite from a very high elevation angle. So this problem completely goes away, and we will have a similar solution. So that is the advantage of having your own system, which is transmitting signal from geostationary satellite like NavIC. If we are from India, there is no problem. So we reported this in this particular paper. Then, so we did a stress test. So this is the NavIC visibility at 10 degree elevation angle. We simulated using our own simulation tool. So you can see over a large region, we will be getting always 7 satellites. Okay, so no problem. So all the NavIC satellites in a 7 satellite constellation, we are getting 7 satellites. And here, only this part, most of the time 7 satellites, only some part 6 satellites, right? So I would request you to look into this part. That means our neighbors, they are also getting the advantage of NavIC, right? So with 20, our most part of India, we are getting at least 6 satellites. With 30 degrees, this very northern part, we are getting 6 satellites. So even if our so-called friends denies their come to get signals from more than 4 satellites to get our own solution. So we are completely independent, mostly from the defense point of view. We are completely independent in strategic application from navigation viewpoint. At the same time, because of from high elevation angle, from the commercial point also, we would get similar solution that will enhance the confidence of our users in using the products or the solution what we have developed. Now let us come to the advantage S-band. So when we added this band, it has been reported here, NavIC performance over the service region. It has been published in Shabna in 2020. So you can see where this is the RMS error values. Just to don't go into how it is calculated. Now NavIC transmits signals in two bands, L5 and S. Right. The third frequency, it is just only one satellite with the third frequency that has been put into the orbit, but still there is some problem of which I will talk about later. Okay. So you can see when we are doing only S operation, the operation is bit better than L5 only operation. Second, so this is our research result during severe scintillations. So what are scintillations? During some periods of the year, basically during March, or when the equinoxes occur, during March, April, May, and during October, November, what happens that the ionosphere, which is a charged layer of charged particles around our Earth, there are certain issues there. That's a completely different ballgame and different, I'd rather say, a different topic. But certain things occur in the ionosphere which disturbs all the RF signal passing through them. The communication satellite, the remote sensing satellite, and of course the NavIC satellite. So disturbances are there. So we take it in another way. So if there is some disturbance in my signal, so something has happened in the ionosphere. So we use GNSS signal to study what's happening in the ionosphere. So it's a fantastic tool, completely free of cost around you, what already I have shown, that from all direction of the sky, you are getting signals, use the signal for your study. Nobody is charging you for using their signal. We have seen during the 0.7, 0.6, that is taken to very serious scintillation, and the ratio of the signal strength into our receiver, you can see the signal strength is fluctuating. So what happens? The receiver electronics sometimes fails to lock the signal, and we don't get. If it happens for more than one satellite signals, it may be the case that the satellite we cannot get a navigation solution. So here you see this is for L band, L5 band. So in L5 band, the S4 is quite high. The carrier to noise ratio fluctuation is very high. At the same instant, you can see when we are looking into the S4 S band signal, that means between 2 to 4, we see that the effect is much more lower, and also the S4 index comes down below, say, around 0.5 like that, moderate scintillation. So that is a unique thing that if scintillation occurs and our receiver works in both L5 and S, L-band signal is completely disturbed. S-band signal signals bail us out in that particular situation. Okay, we have reported this in particular paper. And another interesting thing, or one very serious issue, is the GNSS jamming. So unscrupulous people, they want to jam your signal. Your not so friends want to jam your signal so that you do not get your position solution. So for that, they use this type of very low cost. Believe me, the cost is around 700 rupees. So just put it, plug it into the cigarette lighter adapter in your car, or a very similar adapter. So within 20 meters or 30 meters even, there will be completely blockage of GNSS signals and no L-band signal works. But that's because only India uses S-band signal, only NavIC uses S-band signal. So commercially available L-band jammers are not there in S-band. Although keeping, selling, possessing, and displaying about this type of jammers is completely prohibited by our law of land, but still one can purchase it in many platforms in, I would rather say, below 1,000 rupees. But from the S point of view, as because there is no S jammer, so even if your rail is jammed, S will bail it out. So these are the advantages of S-band signal. Now, for the researchers, once again, the NavIC constellation, I'm repeating it, the NavIC constellation gives a very typical advantage. The advantage is all the other satellites, they move around continuously at 20,000 kilometers and with a velocity of 11 kilometers per second. Okay, so they have got their high Doppler. Secondly, so I want to probe the atmosphere. I know they're using them. So what they does, they rises and they sets. So only for specific time for 3 to 4 hours or more than that, we can do that. And that also from one part of the sky to the other. So the satellite point through which the signal reaches the user, we call it ionospheric pierce point. If you look into the ionospheric pierce point of NavIC, so this is the geosynchronous satellite. So you can see the variation is very small. But we have done one experiment. So this is the ionospheric pierce point for the same satellite, PRN2. This is from our place, that's in Eastern India, from Panhala, that is very near to Kolhapur, in the Western India. So you can see there's certain difference. So from two different angles, we are seeing the same satellite. In case of the geostationary satellite, you can see there is nearly no change. Okay, for me, I can see the satellite whole day at night from one point. So if very small thing occurs at the point where I am seeing, I can study that which was earlier not possible in the signal, because in their case it will be like this. So they goes up and after some period of time they goes down. So I cannot see a particular point. But here you can see using satellites or using the rather geosynchronous satellites also over a small region. So we call it the study the small scale irregularity that we can do. And the interesting result what we received and reported it in this particular journal, that from the same satellite, we are calculating the total electron content. That means one of the parameters for studying the ionosphere. At the same time, we can see the black line is for us and the gray line is for Panhala. Same time at two different locations, there are two types of ionospheric activity. What could not be studied in GNSS signal. So that is the advantage of L-band signal from research point. L-band signal and the typical constellation from research point. Now let us come into positioning. So fundamental measurements in GNSS receiver are not go much deep into. So they are pseudo range and carrier range. Pseudo range or code-based measurements, they are not so precise but very easy. Carrier range based measurements or carrier phase-based measurements, they are much more precise but extremely mathematically complex to solve. The takeaway is the underpin message is, as per our requirement, we can use the pseudo-range-based application, which will give you 4 to 5 meter accuracy at the best, and carrier phase-based measurement that will give in standalone case that can give you order of 2 to 3 meter accuracy in standalone operation. Right. So there are certain errors always which comes into play in the satellite level. Here already I told about as because this is a disturbed region, when the signal passes, the range changes and we get errors. And that is the highest contributing factor in finding out our own position. So there are errors. The solution is how we can take care of the errors using different techniques. So there are different position solution techniques. They can be subdivided into basically three classes. First is the standalone. I have got a receiver, maybe a mobile phone. I am making it on, taking it into a position where we can directly see the satellites. Our GNSS receiver or mobile phone chip, it takes the signal, processes it, and gives you a solution. So the solution Stringent GNSS handbook, as because it was an old research report. So globally, anybody can get 10 meter accuracy, but nowadays we can get using carrier phase-based measurement, we can get up to 2 to 3 meter accuracy quite easily without any. I'm coming to the third, which is quarter precise positioning, PPP. In case of PPP, what is done, we do the very same thing. We are taking data from satellites at any location of the globe. And together with that, we take, pardon?
Hey, Bezu.
Hello? Okay. Please keep your microphones in muted, please. Okay. So in case of precise positioning, we take the data from GNSS satellites together with using internet or using during post-processing. We take data, correction data, to correct all these errors, what I have shown you, to correct all these errors except very local errors from IGS network. IGS is a network of more than 500 GNSS receivers deployed by different agencies over the globe. If you are interested, you can just type International GNSS Service, IGS.probably.org. Everything is given there. So what they did, it's a completely voluntary consortium. So everybody contributing there for improving the solution quality of the GNSS solutions. So they generate the correction factors and transmits to the users. The users, free of cost, can take the data and improve its solution quality. Using PPP, it is still that you can get 10 centimeter, but as of today, using PPP, one can get, say, below 5 millimeter solution. Right, below 5 millimeter in the horizontal plane, even 2 to 3 millimeter, and in the horizontal, in the vertical direction, below 1 centimeter. Third is called the relative positioning. So relative positioning, here we need at least 2 receivers. So this is, let me take the left one to be the main receiver or the master receiver or the base receiver. What it does, it collects data from GNSS satellites and calculates the error itself. Without the network, calculates the error itself and transmits the error within its vicinity of, say, maybe a few tens of kilometers up to 60, 70 kilometers. Right. Then user receiver, right hand side, what is called the rover receiver or the slave receiver, what they do, they take the same data from the satellites and the correction data, what has been generated by the base, and improves its solution. It is called differential GPS or differential GNSS. If we use code-based measurement, it's called DGNSS. If we use carrier phase-based measurement, we call it real-time kinematic or real-time kinematic or RTK. So RTK is the, I would rather say, is the solution because it keeps us centimeter level precision, even order of few centimeters in real time without depending on others. Because if you have your own base system, if you have your own rover system, the base will give you correction factors. Your rover will correct its own location, and at the rover level, you can get order of few centimeters, but it is restricted by the geographical, by the linear distance between the base and the rover, which but typically in a textbook case, it has been told to be 60 to 80 kilometers. But what we have seen and we have reported it, that even up to 200 kilometers using some technique, we can get below 50 centimeter, which is quite good for many applications, below 50 centimeter precision in many applications. So that is RTK. So major NavIC application areas. So now let us go into application. So this is the basic of GNSS methods. But as of now, NavIC has only single point positioning. NavIC has only this. NavIC do not have the relative positioning. NavIC do not have PPP. So this webinar is intended to give you some idea, not only the potentials, but also the challenges or what we need to do. That means till now, the NavIC relative positioning, NavIC RTK, NavIC DNavIC, or NavIC-based PPP is an open research challenge. Many of the organizations of the government of India and many research organizations and academia, they are working on it, but still now a commercial solution or a very easy to get solution has not come in. So the very same thing, standalone solution gives us around 3 to 4 meter or even 5 meter precision. But if we want to get centimeter or millimeter level precision using NavIC, we have to solve this. We have to work on this one. I will tell more about this afterwards. So everywhere where location is needed, NavIC can be used. with the constraint that as of now, it can give you what I told, around 5 meter precision. So where 5 meter precision is sufficient, we can directly use NavIC, no problem. With the advantage that I know if I use NavIC in certain constraint condition, my solution will not get hampered or disturbed because of non-availability of satellites from the high elevation angle. With that typical advantage, together with this, if your hardware supports that, we have many advantages here. So these are the applications in here, I think all of you, because I will give some more examples where we can use NavIC. So if I want to use NavIC for application, the thing is I need to know more about what is the available hardware. So basically the applications can be if we subdivide the applications into two parts, one is completely commercial, real life, real time, mass market, or whatever the name you can give them, and the other one is scientific. So which will support the future commercial application. So this is a non-exhaustive list of geodetic grade receivers. That means very costly receivers which come in an enclosure or with the difference rejecting antennas, etc., etc. So these are the receivers. Java. Once again, it's a non-exhaustive list. So there may be others. What I am not showing you. Java, Philip, Leica, Trimble, they're major manufacturers. And a new manufacturer, what's coming globally into the market with their L5 plus S band receivers, that is NTLab. Also, they have got their geodetic modules, and I put it here because it's a bit costly, around $1,000. That's why I put it here, OEM boards. And I'm very happy to tell to you that one of our friends, I think, I'm not sure whether Lieutenant Colonel Velan is here. He's a good old friend of mine. We worked together, shared successes and failures together. His company, Elena Geosystem, they came up with NavIC enabled this type of geodetic grade receivers. Thanks to him and congratulations to him. Okay, so there are other type of receivers, what we call the record and replay SDI receivers. They also are a bit costly, basically to be used for the use by the researchers. But for us, the application developers, so these are the solutions. So there are this type of very small chipsets which are completely all of the system that can be integrated on a board. So once again, I'm giving you some knowledge. This stock which came very early in the market from Skytrack. Fast to give NavIC solutions with one form factor. You can see the side. The side is really strong. Second is it's a very good GNSS thumb NavIC module. All of them are L5 only, Quicktale, Alistair, etc. But the problem is Quicktale and Alistair, they do not support. Now they're not supporting the customers. Once again, I'm very happy that Elena Geosystem they came out with their first indigenous NavIC chip. And this is the board which they shared with us. So this is the web we can use Jonas and NavIC solution. Once again, thank you very much, Elena Geosystem. But all of them are NavIC L5. So I am listing here what are the available hardware. So Skytrack, Alistair, Telit, and uBlocks, they came up very recently with NavIC enabled modules, major manufacturers in the globally. And Quicktale, Utrack, already I talked about this, Elena Geosystem, NT Labs. And this is the module developed by us. We developed it as a L5 single frequency module. We call it GLBM02. Once again, a very small NavIC module, basically for this type of very low cost application. So other modules which are available in the market, but I'm not sure whether you can purchase them because sometimes Septentrio Mosaic is quite a costly one. It is very efficient here with me. But the problem is, although Septentrio Mosaic tells that it uses NavIC, you can see the NavIC satellites it's tracking, but in its solution it does not use. I repeat, it does not use NavIC satellites. It only shows that it's tracking NavIC satellites, but do not use them. Septentrio Mosaic. So I came across all of them, contacted many of them did not respond. I cannot tell about their performance, but Septentrio is a very good receiver, GNSS receiver, but although it can show NavIC, but it it can collect NavIC data, but it does not use NavIC for solution. Okay. Next, another important thing is the NavIC on Android phones. So probably last week you came across a piece of news that ISRO is working with Qualcomm to come out with NavIC-enabled smartphones. Many NavIC-enabled smartphones are there. All smartphones are GNSS-enabled, courtesy Google, and from them you can collect GNSS raw data for app development and also for research. In many European applications, people are using mobile phones for crowdsourced data collection. Okay, so over the globe, people are collecting data and sending them to them in exchange for a certain volume of data. They're giving them some certification like that, some badges like that, and they're getting data free of cost from all over the globe. For one application, I was seeing that 54,000 customers, 54,000 users of a mobile phone app, they're collecting data for European Space Agency and giving them. They're getting data globally, completely free of cost. So it's a very interesting tool for the spatial science students and researchers for getting a no-cost GNSS receiver, and at the same time for the advanced GNSS receivers, because they can collect raw GNSS data from that one for research purpose. So NavIC-enabled Android smartphones, they came into the market in Q2 of 2020. These are the lists, many more may be there. And Xiaomi 13 Pro 5G is a very good one, which now I use, and I will show that. So these are the so this is the question that older devices through any patch can they use NavIC? The answer is simply no, that they cannot use NavIC. You need to purchase this type of using this type of chipset from Qualcomm or Huawei, so that your phone becomes, so your phone is a NavIC-enabled one. So I collected data last week using Xiaomi 13 Pro, my mobile, and you can see I have showed you two apps. One is GNSS Logger, second is GNSS Test. There you can see that we are getting NavIC signal in our mobile phones, but the bad point is as of now, there is no app in the market which can log raw NavIC data into their smartphones. Very similar to the Septentrio Mosaic. This shows you that yes, it is usable. It is using, but you cannot take NavIC only data. Right. So that is another challenge what we need to solve, and we are working. Our laboratory is working on that one. That to come up with a solution to develop an app which can collect NavIC data in NavIC-enabled smartphones. But in future, NavIC smartphone-enabled GNSS would be a game changer in the whole system, both for commercial applications, for research, etc., etc. Still now, which is very, I would rather say, under discussed topic in the GNSS community of India. So now, when you want to go into application development, you need to know what data the receivers gives. So we call it NMEA data. NMEA means National Marine Electronics Association, and US agency, which certifies and gives a proper format of the data. So here you can see IRN, India system, IRN. So let us take RN or GSS, information about the satellite. So the PLA numbers 2, 3, 4, 5, 6, 9. At that point of time, they're giving it. So satellite numbers 0, 8. There are 8 satellites are being tracked. 803 at 64-degree elevation, 193-degree azimuth with 49-degree hertz signal strength. So this NMEA data gives you the location. So this is the location. Your latitude 23 degrees, 13 point this much north, 87 degree, 53.9455 east. So these are the NMEA data. Complete ASCII, user readable, very easy to use data for normal applications. Simply you have to read the NMEA data, take the solution out of it, and use it for your own purpose. But for research purpose, the more interesting and important data, what we call the RANX data. So the INSS RANX data looks like this, a bit complex, although ASCII data, but directly you will not get the solution. You have to write your own program or use standard programs utilizing this one, so that what it is giving it. So you may think it is the XYZ, what can be converted into latitude, longitude, and altitude. That too, its approximate location. The precise location you can find out using this data, but it is, so you can very well understand that RANX data is for research purpose. If in your application you take RANX data, then in your application you have to write your own program, which will use RANX data to give you a better solution. But in the meantime, 3 minutes has passed, so nobody will purchase that. At least not me. If you give me solution, a worse solution, instantly, at the very same instant, even twice a second, I'll be very happy with 2 to 3 meter accuracy with many applications. So now let us come into a few applications. So where we can use NavIC. Instead of giving, you can use NavIC here or there. I'll showcase you a few applications what I came across in different parts of the globe, what people are doing. So you can see determination of sugarcane harvesters, field efficiency using GNSS system. So what they're doing, they are finding in which pattern the sugarcane should be harvested with the lowest possible time, consuming latest fuel. So this is a study or this is a pilot project what they have done. And in the meantime, the farming or the agriculture had moved towards a scenario what we call the agriculture 4.0, where precision and digital farming are the solution. So where we need location, so where it is working. So for that, we can use GNSS. So in case of agriculture, very easily we can use NavIC. So this is an example project from our laboratory. What we are doing, we have put this type of NavIC enabled modules at different parts of our very near to our location. So these are the potato growing region of our district, and potato is a huge cash crop here. So to find out if there is any relation between the environmental conditions and the potato growth and potato disease and pest infection. For that purpose, we created this type of modules and we are installing here. So automated data will come to us and we'll analyze the data together with verification of the data, physical verification, and we using them maybe some proper algorithm. Can we come out with a solution which will predict when the pest infection may occur in this particular location? So only these areas farmers need to spray pesticides, not this. So it's environmental friendly for sustainable development also. So we are working with this thanks to DST sir for sponsoring our project. So intelligent transport system, like a very fun, but you can use this type of scientific application. GPS technology of any aquatic charting. They put GPS receivers on without having the GoPro. They are putting GPS receiver and tracking where it is going and doing this. Similarly, inventory plots for high distribution studies. Here, GNSS in tsunami monitoring study. So for monitoring the tsunami, so these are the tsunami monitoring buoys as they please. Some 20 kilometers away of the coastline. So if please sir. So if 20 kilometers away, some high tide is there, the buoy will be at this place. So some appreciable change in height, so they can generate a tsunami warning. This type of application is coming up, but for this type of application, we need NavIC RTP. So landslide barrier, seismic landmark after a major fire. So the QZ disaster alert system. But I want to give you, not exactly NavIC can do this. So people are doing it in different countries, all these things. So we Indians can use our system for this type of application, what is appropriate for our socio-economic condition and needs. And the future market, obviously IoT, where location is an integral requirement. So providing both the position and the time. So I don't need a physical clock. The satellite data will give me precise. I'm not sure whether you know or not that all our time, global time now is synchronized with GNSS. So all the time comes from the GNSS. So now your NavIC module is a source both for positioning and timing. So in an IoT infrastructure, we can use them because each of the IoT component needs its own unique ID together with its location and time stamping of data. So it is used. And in future, drones and UAVs could be the ones. And here comes the mHealth, the mobile health. Raviji, how much time I have? Can I go for 10 more minutes? Or
Sure, you can go.
Okay, thank you. So mobile health in your future would be a game changer. So we have seen in the pandemic time when we could not visit the hospitals and the doctors could not visit us physically. The mobile-based or the app-based consultancy services saved our lives. Now people are thinking of how to manage the patient in a critical condition. For example, a brain stroke or a heart stroke. But the next 1 hour is very, very critical. If the patient can be taken to the hospital or within 1 hour, the life would be saved. But the problem is, typically in India, sending ambulance to his or her place, then negotiating the jams, taking the patient to the hospital, and then judging, making a preliminary judgment what has happened, and then the treatment starts. It may surplus the golden hour. Instead, what now in many countries it has been thought of that there would be for example, you have got your own company who manages the help of elderly people. So you have developed an app. That app is distributed from the app. Whenever some elderly people, he or she is ill, simply he or she will push a particular button, red button in your app, which will always be floating. So when he pushes that one, using your mobile phone's GNSS chip, your location together with the distress signal, this goes to your company. Now your company knows where the patient is. Now your company sees where exactly the different ambulances are there of your fleet, and it finds out where is the nearest ambulance. Maybe it is very near. After dropping another patient, it is going back. So it is tracking it and tells it you rush back to that particular place, take the patient, and this is your shortest possible route. And during the transit, the paramedics measures some of the vital parameters of the body so that it reaches to the hospital. The doctors know how to start the treatment. So this is an excellent solution or excellent advantage. Second is emergency drug delivery. I need a drug. Within 15 minutes, it has to be pushed to my body. But if I order it, they will deliver it in a motorbike. It may take a long time. So people are thinking of drone-based drug delivery, which is the shortest path. Right. So that may be the case. And let us see this. So, of course, for the drone-based application or UAV application, we need precise positioning to control them. And here, NavIC, for our country, NavIC can be a solution. Sorry. So the challenges. I'm coming to the last part. The challenges. What are the challenges you are facing? Obviously, already I told that NavIC, RTK, NavIC. These are open challenges. Although people are working, but we need more and more people. The next slide will tell you. Okay. Now L1 enabled hardware. Till now, all the hardware that we have got only L5. NavIC L5. NavIC L1 enabled. Although satellite is already there, but we cannot exploit the frequency. Using 2 frequencies, we can improve our solution. There are techniques, mathematical techniques. So, but NavIC enabled hardware, what I foresee using my contact with the industry, that it will take nearly 6 more months, 6 to 8 more months to come for the hardware to come into the market. But obviously, they're coming into the market. Then cost efficient S-band antenna. So L-band is 1 to 2, S-band is 2 to 4 gigahertz. So for this huge bandwidth gap, the S-band antennas, what are coming into the market, they're quite costly. But for more use or popular use of the technology, we need very low-cost cheap antennas like GPS. What you can find in Amazon, maybe 15, 5, 10, or 20 US dollars. But S-band antennas, now it is 60, nearly, you can say, $700, $800 you have to spend for an S-band antenna. So that is another challenge. Can we develop very low-cost S-band antennas together with L-band application? Then NavIC timing capabilities. We are using NavIC positioning. We can use the NavIC atmospheric research. That's fine. So NavIC can also give us time. Can we use it for timing capabilities? What are the timing capabilities? Still, not much research has been done. Fortunately, our group got a project from Indian Defense to study this one. We are working with this one. And studies on interference and jamming resistance and more real-life application development. So finally, NavIC is now available for use over its service region with multiple advantages, ready to shove some nations into the civilian science and protective strategy, can enhance multi-genus potential for system independence, redundancy, and confidence. Hardware is being increasingly popular. Low-cost, cheap hardware is usually and power efficient chips are available. So we must take the advantage of the situation that we must now think of a particular application area, what are the challenges, how to integrate NavIC into it and exploit the situation and support the community. It is got immense application potential. What I foresee that the academia, research, industry synergy, of which already we have just heard that TIH hub will be the boiling pot for all these things. And we researchers hope to see that we get all sorts of help from this type of hubs, so that what we are doing in the lab that can be propagated into the society for the benefit, once again, for the benefit of the our countrymen. The technology is completely for them. Everything has been developed using their money from their pocket, using their taxes. Okay. So upcoming opportunity. First thing is Response Basket 2023 has just been published by ISRO. So it is a call for research proposals from the researchers. Nearly more than 100 topics are there, including NavIC interference studies. Okay, anybody can go there. If not, you can drop in a mail to me. I will give you the document. So you can find out a particular research problem. You have to work with a particular ISRO laboratory with one of the scientists as the co-PI. But it's a fantastic opportunity for everybody to put forward their research ideas. The last date is 31st January. The second one from the IIT Tirupati Navishkar Hub Foundation, Chanakya Fellowship. It's for UG, PG, doctoral and postdoctoral fellowship. The last date for apply is 31st December. More can be provided by Peraviji. And on 25th of January next month, there is a whole day, one-day online workshop on NavIC development scope and opportunities that will be delivered. It is a co-sponsored by URSI, and we are expecting, I'm one of the co-chairs, and we are expecting that by this week we will float the announcement, and people from industry, including ISRO, Research Lab, industry, and academia will be showcasing about NavIC. Hopefully, this flyer or the announcement would be made. We are nearly ready. We are just struck with one or two minor points. Probably maybe tomorrow, day after tomorrow, definitely within this week, the code will be there. So once again, first of all, thanks to the organizers for giving me the opportunity to share my thoughts. Secondly, to all our sponsors, using whose money we have developed our laboratory and we got real hands-on experience. Thank you very much, and I would request you, everybody, to visit our laboratory, view GNSS in, or if you scan the code, it will land you to our page. And in our page, generally, we put forward all opportunities, globally all opportunities on NavIC-based training. And last but not the least, I can see 95 people at 7:35 or 7:40. So after a hectic day's work, hard work, after going back to your home, you have given me your time to hear me. and you extended your hands to the organizers. Thank you very much. I should once again congratulate and thank you for your support. Thank you. I'm stop sharing and I can take a few questions, maybe 5-10 minutes. Thank you once again.
Thank you, sir. So just to add upcoming opportunities, I would like to share a few details about our upcoming event. That is totally focused on NavIC. The event is happening on January 22nd and 23rd at Bangalore. So
Okay.
this is focused totally on NavIC, where you can learn about latest technologies and developments and applications on that. It is also a opportunity for you to meet representatives from industries, startups, academics, and also the government agencies. So I will share you all the details through email for all the participants. So you can interested if you can participate in this event. So now we are open to questions. So please, if you
Yeah,
have.
good evening, sir. Good evening, sir. My name is Lokesh, sir. I am from Miltronics Private Limited. I was a early stage startup, sir. We are working on autonomous feeding to the fishes, sir. Autonomous boat, sir. It was the autonomous boat to feed the fishes and prawns, sir. Here we are facing the issue of navigation problems, sir. Now we are using the GPS system, sir, but it was the differences of 2 to 3 meters, sir.
Okay,
Is this NavIC was helping us to the
I'd
hardware?
rather suggest as because it's an open platform for case-to-case specific things. You can directly. I have given me your just to share my contact details once again.
Yes, sir.
The presentation of the. You can directly contact me. I have to explore it more. It will be very unjust that simply I'm telling you yes, it's possible. No, it's not possible.
Yes, yes,
So,
yes.
okay. So better to contact me in this address. I'll be there. And
Sure.
I'll better to take some very general questions from the understanding point of view or something like that.
Yes.
Okay.
My question was, as a startup, where should we get connected to, explore business opportunities in these areas like drones and IoT and, UAV and all? Where should we? So we are contemplating getting into this business area, and we have the, the manpower, but we are looking at where should we get connected and how should we explore the business opportunities. We are very bullish on this.
Okay. Bharat is there. I think he's the best person to answer you. Bharat, are you here?
Hello, sorry.
Okay. Mr. Radharajan Krishna, who was there, he's a mentor and advisor to the TIH.
Perfect.
Okay.
Dr. Anindya, you are looking for Velan?
No, Dr. Bharat Krish, I'm looking for.
Achha.
Okay.
Okay.
No problem. If he's not there, we can take up I can take up the question that way. That, sir, to me, the opportunity what is being provided by TIH, I have mentioned it to be a melting pot. So this may be a good opportunity with the people. Both what I feel that in many cases I come across people who have got the problems, and the academia we have got some solution. We do not know how to use it. So there should be some handholding, and TIH may play a good role here. Exactly, I cannot tell you. Yes, you contact this person.
No. We are not looking at handholding. We're just looking at some leads where we can take this. So I will be in touch with you, and I think if there is any guidance required, this is Vinay Savarkar from Cladroid Technologies from Mumbai, and we will be in touch to take it forward.
Sure, sir.
Yeah? So if you can, one more request, if you can get the copy of the presentation, post this event, post this presentation, post this session, That would be great.
Okay, so what I will do, a few things I cannot share, only one or two things that I will take out and make a
Perfect.
PDF
Perfect.
copy and
Perfect.
share it with the organizers. Raviji, I will surely I will greatly.
That would be fantastic. That would be fantastic.
Thank you very much.
Thank you. But your address should not be removed. Thank you so much. Really appreciate this session. Thank you so much.
So good evening, sir. This is Dr. Roshan Srivastava from IIT Tirupati. I'm the project director for Technology Innovation Hub. So Vinay ji was just talking about the opportunity and all. Sir, I would like you to kind of get connected with our Technology Innovation Hub. We have the advisors, we have all the team ready for NavIC. Basically, we are kind of pushing NavIC hard.
Perfect.
And in fact, I've just shared one of the upcoming events. I'll be very happy if your team can come down to Bangalore and then join this 2-day seminar, which is jointly conducted by BEL India and as well as IIIT Bangalore also is joining. Other than that, I think we are trying to bring in most of the big shots and big experts in NavIC who should be able to kind of, give you an overview like what you have been looking at now as a market, as a
Yeah. Perfect. 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 Thank you so much.
Hello, Dr. Roshan. I heard about you, so this is the first opportunity at least virtually connected to you. Hello. Okay, any more question or any comments or anything?
Good evening, sir.
Yeah.
Sir, this is Shubham Saxena, and I am a MSc first year student from IGNOU.
Okay, hello.
So,
Hello.
sir, so sorry to disturb you, but actually I joined late, around 7:10. So I really need the recordings regarding the upcoming events, and so for a better understanding, and so that is why.
Oh, I think that will be taken care of by the organizers.
Shubham, you can
Yes.
contact me, so I will give the recording.
Sir, the same mail ID that you.
Yes.
Okay, so it will be shared over the.
All the participants, I would say, please keep visiting our website, iittnif.com, where we are keep posting all our programs, including the fellowships, opportunities for startups. In fact, there's a lot of calls for startups and technology development products. So this is an initiative from the Government of India, where I think I've just shared the IIT-NIF website in the chat box. If in case if you have anything, you can write down also to Ravi or go to our website. We can leave you all the details.
Okay.
So
Sir,
please feel free to contact.
Okay, thank you, sir. Thank you.
Yeah.
So any more questions?
Any other questions?
All right, I think we can close this session. Sir, I would like to thank you, Anindya sir, for your time. So it was really incredible presentation and on the topics of multi-GNSS and what are the NavIC differentiators, what could be the innovative applications you can create through NavIC. So the presentation was really good. You have given a pool of knowledge to our audience. Thank you again for sharing your knowledge and expertise with us. Sir. It is truly valuable for us. So thank you for your time.
Okay, thank you very much to the organizers, to the participants. Have a good late evening. Thank you very much.
Thank you all. Thank you all. Have a good day.
Thank you, sir. Thank you so much.
Thank you. Thank you, sir. It was wonderful to hear you.
Thank you.
And I'll see you in Bangalore for sure.
Yes.
Yes.